Good afternoon. I'm Yohei Dong from AI System Team. Today, I will talk about On-Device AI Studio, which is on-device AI development environment. First, I will briefly introduce you to why we needed AI Studio and some of the functions provided by AI Studio. So let me first talk about on-device functions and how we came to develop this. In the early days of on-device AI, each feature shipped as its own fully fine-tuned model targeted to a single task. As accuracy targets rose and the number of features increased, model sizes grew and the total storage footprint ballooned. To overcome this, we adopted a design that places a high-performance generative foundation model, known as LLM and FM, on the device and adapt it per feature. So we have selected high-performance generative foundation model. With Galaxy AI deploying an on-device LLM and FM, something we hadn't done before, has enabled faster and more efficient expansion of AI features. To adapt capabilities on top of an on-device LLM, LoRa fine-tuning was essential. Developers started to define the target feature and then prepared large training sets and then established clear evaluation criteria. They then trained multiple LoRa variants over the data, followed by quantization and runtime optimizations for the models. So the resulting models are evaluated against required quality bars using several methods. When needed, we strengthen the test suite, augment the dataset, and reiterate retraining and reevaluating until the feature meets the desired performance. So let's look at the AI Studio functions that effectively enables development of such AI functions. AI Studio first develops the development environment for developers to develop the AI functions they need using generative AI. First, there is Prompt Studio that enables AI function development just with the prompts. And there's the Adapter Studio that supports LoRa training and optimized training pipeline. Last but not least, there's the Evaluation Studio that enables the verification of the adapted results and performance evaluation. First, the Prompt Studio, using a model with far stronger instruction following than the LLM shipped on SAIF2025, it lets you build AI features without LoRa fine-tuning. It uses prompting only. Developers can author prompts using prompt templates, apply techniques like few-shot prompting, and see the results right away. Because this approach requires no data preparation or LoRa training, it naturally increases developers' productivity and enables faster proof of concept for a wider range of new AI features. Prompt Studio can also optimize prompts automatically, suggesting versions that perform better on our LLM than the developer's initial draft. So it will enable novice developers to try developing the prompts. Next is Adapter Studio. Because of on-device LLM size limits, many features can't meet production-grade quality with prompts alone. In those cases, developers need LoRa fine-tuning. Adapter Studio provides an automated pipeline to train language and multimodal LoRa on top of a foundation model. It automates the complex training steps and offers progress monitoring so developers can apply a variety of fine-tuning techniques and build adapters easily without micromanaging every details. As I've mentioned before, achieving production-grade performance with LoRa requires an iterative loop, training on large data sets, optimize and evaluate, and then augment the data and retrain to push quality higher. For Galaxy AI, multilingual support means collecting language-specific data sets, and real gains come from high-quality data augmentation. In practice, data quality and coverage determines model performance in many cases. AI Studio automates the most time and labor-intensive part of LoRa fine-tuning, securing high-quality training data. Once developers provide a clear feature definition and evaluation rubric and a small seed dataset, AI Studio uses a large teacher model to auto-augment data, continuously analyze how each augmentation impacts LoRa performance, and iteratively distill the most beneficial examples. Repeating this loop yields curated corpus of high-quality synthetic data tailored to the target feature. When building on-device AI, the biggest departure from server-side adapters is the quantization stage. In Adapter Studio, once adapter training finishes, we run an automated pipeline for quantization and graph optimization. We mainly use two approaches, PTQ and QAT. PTQ needs no extra training and is fast, but some models can suffer noticeable accuracy drops. In those cases, we apply QAT to recover quality at the cost of additional training time. AI Studio automates this flow and produces chip vendor neutral, quantized artifacts that can be compiled for different NPUs and SoCs. Finally, let me introduce the model evaluation functions for AI Studio. For generative models, rigorous evaluation is as important as development. Evaluation Studio supports testing not only text but also multimodal inputs such as speech and images, reflecting the input for IoT supported in Galaxy AI. It offers multiple evaluation models, including automated judge with large LLMs and human-in-the-loop qualitative review. You can also track performance through the final quantized on-device model, ensuring that any accuracy shift after deployment is fully captured. That's the overview of AI Studio today. So what's next? We plan to extend our automatic synthetic data generation from text-centric to full multimodal so that Galaxy AI can deliver more user-friendly experiences. We are also working to automate evaluation prompt authoring and to generate test cases that better mirror real usage, boosting perceived quality. Finally, we will strengthen multilingual support, helping developers who are relatively less familiar with cross-language workflows achieving strong results. And this is some of the questions that we have received and about the future of AI and the long-term direction of AI semiconductors. But these are too difficult a question for me, so I want to answer two of the most practical questions. First, is there a single Swiss Army knife stack for training and deployment? I have used the TensorFlow Lite so far, but we had to run it in specific runtime, though Onyx helps a lot with interoperability. On mobile devices, we use in-house runtime. So the question was single Army knife stack for training and deployment. Is there any such thing? We haven't found one yet. For training, depending on the training environment requirements. We sometimes use TensorFlow or PyTorch, and we use various training framework, and then we sometimes change the models. And Onyx is very helpful for securing interoperability, and mobile devices we use our in-house developed framework. Samsung has very diverse configuration environment. We need to run on CPU, GPU, NPU efficiently across many SKUs. Some of the framework we need has been shared via Tizen, but more remains to be released. Our hope is to let you try the Samsung Research AI runtime directly and collaborate on its development. The second question, what is the most difficult challenge for resolving satisfying the user's requirements who are used to using large-scale models such as on-device LLM? We actually don't have a solution for meeting their requirements future. We have clear resource restrictions on terminal, and that is the biggest challenge for us. I would like to thank once again everyone for the thoughtful questions. That concludes my presentation. Thank you very much.